And so, Mike, while folks are loading in, I'll share a Dropbox link after with you,
Okay.
so that you can share this presentation. It's 60 slides, but I don't plan on covering them all. I just
Okay.
felt like it was better to have it in the final presentation that gets shared with the teams in case there are more questions, or some of the folks may want more information than we're able to cover in a short format like this afternoon.
Okay. That sounds good. You can even stick it in the chat box if you want. Then we'll
I
tell
should actually
everybody
say,
it's there.
I got to remember the time zone.
Yep. Welcome, everybody. We're just letting everybody load up. Thanks again for joining us today. Another few minutes here, or a few seconds here, we'll get going. Okay, looks like we're pretty much up and ready to go. Thanks again, everybody, for joining us here. We're going to talk a little bit about filter technology and some filtration today. We've got Patrick Verwys from TripleClear, who's going to be our presenter today. We've also got Dave Greenheck from Hurley. He helps with the engineering side and all that goes along with being engineer, because he's an engineer himself. And we've got Devin Carl, who's our vice president. He's on the road today in Eastern Washington and Idaho, so he'll be on the back side as well. We'll be watching the chat box and the Q&A so we can answer your questions as we go. We'll, as always, have a drawing at the end, so we'll announce that once we're finished. I've opened up the chat box and Q&A, so if you have questions, please do that. We'll be watching that closely, and we'll answer those questions as need be. So with that, I'm going to turn it over to Patrick to give us our presentation today, and thanks again for joining us, Patrick. We appreciate it.
It's my pleasure, Mike, and it's good to see everybody again virtually, and looking forward to hopefully seeing each other in person here, whether it be at ASPE or ASHRAE or when I'm next out in the Pacific Northwest. But it's kind of funny, Mike. I feel like we've been doing this for I feel like everything's new, and we haven't been doing this very long. But I look back at my notes, and I first met the team in 2017 and had my first trip out to work with the engineers in the area in 2018. So I guess that's why the gray hair is becoming more prevalent as the days go on. But what the team thought would be beneficial for everyone's time today is to take a look at the evolution of our program. And so just for everybody's sake, we do a lot when it comes to potable water safety, as well as potable water sustainability in commercial buildings. And that runs the gamut between schools and public and higher education to, simple mixed use or commercial real estate, commercial residential, excuse me. We're doing more and more in the medical space with assisted living and hospital projects that we're happy to answer any questions you may have. But for today, we're going to focus mainly on what the evolution of the TripleClear program has looked like, looking at one specific vertical, which is hospitality. And at the end of the day, as engineers, the water feeding these buildings are the same. And for the most part, a lot of times the people occupying the buildings are the same, whether they're there as a hotel or whether they're there because they need, surgery or they're visiting a loved one in the hospital. So ultimately, at a high level, our organization remains very committed to water technology. We spend the vast majority of our time talking about our force field technology. But as we stand today, we make and include in our designs over 90 different types of filters that are all designed to accomplish the same goal, which is take water quality that may not meet an expectation of one of our clients and come up with a very cost-effective and a very efficient way to get it to the level that they're looking for, whether it be force field as the gold standard or whether it be like projects we're working on in Seattle where we're just trying to get iron out of iron out of a domestic hot water loop in a building that's 60, 70 years old, right? The key there is whether it's Dave or Mike from Hurley, you've got some really smart people that are on your side and willing to help locally. We want to be the resource that gets them there. Specifically to force field, just in the back of your mind, keep kind of keep in perspective that it's a mechanical filtration property, which is a fancy word for a cartridge-based product. Our products range from 1.5 gallons per minute up to 1,200 gallon per minute systems. The key is to effectively, efficiently, and consistently mitigate microbiologicals like bacteria and virus, while also making sure that we're taking out other contaminants like metals, endotoxins, trace pharmaceuticals, doing it efficiently, and making sure that we've got systems, whether it be a small point of use filter or a large system that is designed smartly, with as minimal footprint as possible, with very little to no energy consumption, and making sure that the water that enters our systems are being used to the best of our ability. So ultimately, what are we talking about as the problem? That picture you see on the right, I share regularly. So our office is in Wellesley, Massachusetts. So I stay at the Boston Marriott pretty regularly. They know me. They are finally a customer of ours after many, many years of telling them what was wrong. But as we got to the other side of the pandemic and I started staying in their property again, it was over a year that I looked at that filter that had a date on it from prior to 2020. And it wasn't until November of 23, that's the last picture I took, that filter was still sitting on an ice machine at the end of a guest room hallway. Why is that important, right? It's because what we don't see in water is what could be the most harmful for us, right? And so the pictures you see, we often reference here in the bottom left, that's a penthouse that we took those images of where it's the exact same water. One is domestic cold, one is domestic hot. But at the end of the day, what we see can be a concern, but really, as I mentioned, what we don't see is the bigger issue. So what is the Marriott Newton facing that so many different properties are facing? It's the fact that they're understaffed. There may not be a water management program in place, but more importantly, I would say a lot of them are taking that first step to want to ensure either great tasting or safe water, but ultimately not being there to deliver consistently is a major issue. So people laugh. I probably have almost 1,000 pictures of water filters on my phone because I look everywhere I go, whether it's a drinking fountain at school or whether it's a ice machine in a hotel. But as you can see, these are some recent ones I pulled together, dated, install April 4th, 2021. I took that picture in October. This one I took in May of 2024. Here's your maintenance log that was last touched in 2020 on the side of the ice machine for guests to see. It's really something that this picture I just took a few weeks ago, FYI, that actually was a hospital, a children's hospital. I can't tell you where it was, but front and center for everybody to see is a product that has not been properly maintained and forgotten about. So our partners continue to grow because of who we are, what we've been able to prove, but more importantly, what we're able to consistently deliver. So these are some proud people. Today, we're going to take a deeper dive into hospitality, like I mentioned, but we'll talk a lot about Marriott, but I want you to know that they're certainly not the only folks that we're working really closely with, and this list probably needs to be updated because we've had a very, very busy 2024. Ultimately, where it all started. So for some of the folks on today's meeting, you've heard our story, but it dates back to a few being two co-founders that started to get frustrated with the idea that they were constantly being handed plastic water bottles when they traveled because they had status, because they traveled all the time. Our one co-founder jokes that when folks ask him where he lives, his answer is a Delta Sky Lounge because that's his world, right? But ultimately, they, like so many entrepreneurs, took it upon themselves to try to figure out if there was a better way. So coming from outside the industry, they had a fresh perspective. Ultimately, that fresh perspective led them to our first pilot, which was 1 Hotel Miami. So it was about 2 years of engineering before that first project was updated, was commissioned and brought online. But what you see is a 600-room hotel in Miami that utilizes a small 400-gallon per minute system that will deliver bottled water quality to every room, actively marketing it. The interesting thing is, shortly after this hotel opened, one hotel is managed or owned by the Starwood Group. Starwood divested their brands to Marriott, and we met this gentleman right here who is pretty integral in a hospitality vertical, and that gentleman's name is Terry Smith. He's recently retired, but he was the senior vice president of global engineering for Marriott. That's a picture we took in his office in 2018. That's water that he routinely drank from our from our water bottles and filters as he started to really share his passion for what we could do together with the folks at Marriott, and openly put them in a position of vulnerability to be the pioneer in the industry. So taking a quick step back, the evolution started with guest room filters in the Element brand. So again, not necessarily solving the problem, we're really solving the issue we talked about earlier, which is, you know, their filters, folks are taking that first step to do the right thing, but ultimately, are they, if they're not maintained, are they achieving their goal? And so we installed guest room filters. The experience was fantastic. The filters we designed for this environment have a built-in fail-safe. As anybody knows, with force field, you'll start to load or lose pressure before you see any performance degradation. So ultimately, from a safety standpoint, we knew we would get a guest complaint prior to them having a situation like you see my ice machine at the Boston Marriott. But we knew that wasn't the most efficient way to go, and we knew that we've already solved the problem and really cracked the case with the Starwood Capital Group before we got involved with Marriott. So our second project was just that. We did a hotel conversion. So this was a fun project for us. So this is Odessa, Texas. If anybody's ever been to Odessa, Texas, yes, they have water quality issues. West Texas, you know, downtown, you know, you feel like you're on a 1960s movie set. But ultimately, there was a development group of some oil folks who bought this building here, which was a movie theater. And then they built this Marriott, developed the area, and they continue to develop the area, but they built a convention center and hotel. And we were able to put our first point of entry system in that feeds that building, and was a great success. So then where has it evolved till today? So I just grabbed two examples because what we're going to get into next is the detail of how Marriott's design standards have evolved. But ultimately, whether it's a new building, a conversion, or a renovation, whether it's a select service or entry type flag, or they call them flags, but brand, or whether it's a Ritz-Carlton, the design standard is verbatim and it's exactly the same. So from an engineering standpoint, you'll see it's really nice for us because we've been able to standardize our selections. We've been able to really work closely with the design engineers at Marriott to limit our footprint. So point of entry becomes a very viable option, both footprint and cost. But more importantly, we've also then streamlined it. So as an engineer, these become very repeatable in terms of your projects. But what you see here is the point of entry system in the mechanical room. We've all been forced into these situations where we don't have any room. The good news is we've been able to build this vertically so that it can go against the wall and ultimately take up a small footprint and deliver impactful results. Then this particular hotel has, and you'll see why in a few minutes when I take you through the standard, they also have our domestic hot water safety systems on each zone. So all in all, you've got 3 systems now that cover the point of entry, so every drop of domestic water makeup, but equally as important, we have a check and balance of a hot water recirculating, a system on each of the hot water recirculating return loops for each zone. So this was something we did about a year ago. We've got countless examples. These are just some nice pictures that I thought would tell the story well for today. And then we go right into just a few weeks ago, I was down in Florida doing this startup. This is a Ritz-Carlton residence. So it's an 18-story building, all condos, and there's a second tower being built. But this is a 400-gallon-per-minute system where they're actually actively marketing to those condo owners, spending $30+ million a unit, that they have the ability to really leverage the sustainability of having a TripleClear system and drinking great water from their taps. So, like I mentioned, we wanted to talk about the evolution of the design standards. So, for today's conversation, because we're talking to folks here in the States, the target is really all of North America. So this is the U.S. and Canada. We are also the design standard for the Middle East and Caribbean, Latin America right now, with active plans to continue to support Marriott's development outside of the U.S. For those folks who are working on hospitality projects, the current Marriott pipeline that was just released in August of this year, so just a few weeks ago, for Canada and the US is just over 1,700 hotels. So there's a lot of work to be done, and that's why I think it's so commendable that Marriott took those steps in 2018 to really pioneer and look at how they could build a different building than we've always done. But ultimately, some quick definitions that are taken directly from their design guidelines. You have a design standard, which is your minimum requirement to be fulfilled without exception. Again, this is directly from their design standards. And then you have best practice, which is just that. It's a recommended way to execute a design standard. So where did it all start? So like I mentioned, in 2018, we were written in for the first time to Marriott's design standards. This taken from April of 2018. As you can imagine, we did not necessarily do a great job of keeping it simple. And anybody who's worked with us in the past and understands the power of force field, you can quickly see why some of these numbers matter. But ultimately, as an engineer, where I felt like the standards did not go to the length to support your efforts the way they needed to, was simply this final line, which is which was obtain a current water analysis. It's a little ambiguous. So ultimately, it put the onus back on the group, saying, look, you need to deliver these levels. But anybody who lives in this water treatment world knows that they basically match what your Safe Water Drinking Act levels should be, right? And so at the end of the day, no matter how much effort we would work on it and really spend the time understanding how to integrate what we're trying to accomplish into the design of a new hotel, we would essentially send our engineer partners into value engineer meetings, and we weren't very successful. So as folks who work with Marriott know, every 3 to 4 years, they revise their standards, or they go through a revision process and revise areas that they want to. So released in March of 2020 was our effort to help simplify this language. And I say our effort because our team at TripleClear was very involved with this, because we knew that we had great feedback from the community that the intent wasn't actually being practiced. So as you can see, we took the chart out and we went to a little bit better of a definition of what water needed to be, what the water quality needed to reach. We obviously expanded it to the WHO as well as the US, the Safe Water Drinking Act, because we were working on expansion at that time into Caribbean and Latin America. But this is where, to me, the definitions, took a significant step in evolution, right? But not necessarily going far enough. And it always is that great candid feedback we get from the engineering community, and quite frankly, the developers themselves, that helps us understand, where our words, or how our words, I should say, are actually being interpreted. So now we took it a step further, right? Provide a package point of entry system that meets a requirement, right, of water. That is important. but that maintains, and I won't read this to you, right? But that retains, bacteria. So we're making sure we're covering that. And we want to make sure that for us, the other big thing is endotoxins and biofilm, right? So it's one thing to treat the water, but we want to make sure we're capturing everything that's in the water so that we're not kicking the can down the road. Ultimately, then it went further to define point of use filters and where those point of use filters should be applied within a Marriott property. Again, reinforcing some of the language with regards to microbiologicals. In full transparency, water quality is critical, but Legionella and bacteria are ultra critical in this environment just because of the sheer exposure that a group like Marriott has, when people get sick. And then we took it a step further and introduced domestic hot water. This is what I was pointing out with the Town Place Suites reference I showed you earlier from Ocala, Florida. But as you notice, in each opportunity, our goal was to reinforce the performance aspect of what we were trying to accomplish. So not only deliver water to every fixture, make sure it's compliant or meets minimum standards with Safe Water Drinking Act and World Health Organization, depending upon where you are in the world, right? But then also, these are the critical areas in the building where it matters. Point of entry, your domestic hot water recirculation loop, and then point of use applications where a guest is going to come in contact with water. And then ultimately, the language was added, not only that TripleClear was listed as the, as the manufacturer that meets the standard, but they made sure, oops, I did it again every time I try to click on it. They made sure to then further put pressure, quite frankly, on the engineering team, because they know that ultimately you guys are going to be on the front line of these conversations. So with that said, we introduced this in March. I say Marriott introduced this in March of 2020, and we all know what happened right after that, right? We headed into a period where, the pandemic began, or the pandemic really hit us. I shouldn't say it began, but with that, Marriott furloughed a number of, furloughed their entire staff, but then when they brought them back, they reduced their headcount drastically. And so we've been in this catch-up mode since March of 2020, ultimately really digging back into this in December of 22. And again, we sat together as a group in Bethesda and really looked at, okay, well, what is the feedback that has been received? Like, what are people saying? And I would tell you that the number one thing that we hear, and anybody who's worked on a project with us may or may not also hear, is this almost became a get out of jail or clause, right, for the developer, which is essentially, if I obtain those words, obtain a current water analysis, if your developer would just supply you with a water analysis from the city, you call it this, the city of Portland, right, wherever it may be, that says their water meets the Safe Water Drinking Act, well, then nothing else needed to be done. Right. And ultimately, that wasn't the intent. So point being is, it was time for this to reach another evolution. And so similar process, all of last year, we went through a number of different revisions and collaborated with some of our key partners. And ultimately, this is the current standard that Marriott just released in April. And the parts that I highlighted, I think, are two of the keys that are different. So again, if you remember the last one, it was point of entry, provide 3-stage factory, factory package system that meets all these requirements, right? In this particular case, now we cleaned it up to just a multi-stage point of entry purification system. But projects without the point of entry system shall provide the secondary systems, right? Secondary is now defined as a hot water system, right? Like we talked about, and your secondary point of use filters. So, and then again, there's no areas here that have been added. The language has just been strengthened and clarified. Easy to say. But ultimately, then the other parts of the performance criteria we're now taking down into filtration requirements. So rather than have these big blocky areas, right, with information that that you need a chemistry degree to understand, we wanted to clean it up. And so the number one thing that they wanted to clean up that I think is so critical for anybody working on point of use specifically, point of use applications, whether it be a drinking fountain or an ice machine or any type of point of use filter, is that carbon block filtration is not acceptable. So what's so often overlooked is that carbon is an exceptional media for filtering water, but it's exceptional at removing metals, which is the majority of the time what our target is, right, folks? We want to make sure that lead is not, not being consumed in our drinking water, or iron or copper, just metals, right? But equally as important, it's extremely good at removing bacteria. But what happens is the bacteria itself is not mitigated. So now all of a sudden, that filter becomes a breeding ground, a potential breeding ground for bacteria that then leaches back out into the water stream downstream. So what Marriott has realized, finally, to put it in writing and take that significant next step, is consistent with 30-plus-year-old EPA language. And if you look at the majority, you'd be shocked if you picked up a carbon filter that did not carry the EPA warning, which is do not use, I'll paraphrase for a moment, do not use if the water is of unknown quality or microbiologically unsafe. So it takes you back to that application of a hotel or a hospital or anywhere, right? Are you regularly testing your water? Because if you're not regularly testing your water, you should not use a carbon filter. And so Marriott realized that after doing a whole bunch of due diligence and taking that progression that, quite frankly, is in line with CDC now. It's in line with our ASPE guidance. It's very consistent, but commendable for a group like them to put that front and center as the first line. So then ultimately you could see that they go through the same performance criteria that we've been working with since 2018 in their standards, just continually revising it, hopefully getting to the point where it's consistent, but also it's understandable not only from the design community, but most importantly from the development community. So with that said, I'm happy to take about 10 minutes and dig a little deeper into the force field technology and kind of what makes it so special. But thought this would be a good time to take a break and answer any questions that you may have about this evolution.
Patrick, I'm not seeing any in the Q&A or chat, but a couple of questions I have is on that last screen you had on the filters, you said there's a 3 PSID max clean pressure drop. Is that per filter or is that overall system pressure drop?
Great question, Mike. Yeah, so that's an overall system drop, regardless of it's an ice machine filter or a 1,200 gallon per minute system. So what that means, so, and I can get into the detail, but for anybody who's worked on filtration systems in the past, our force field media carries a 1 micron nominal rating. So that's going to be your standard pressure loss across any 1 micron filter.
Thanks for that.
And
yeah,
just to
go ahead,
get a little bit more context, the reason why they want that there is because ultimately ultrafiltration is really good in this, in terms of solving these problems, but it can be very inefficient at this level. And so that's their way of really kind of talking about the performance, but not looking to put a whole bunch of ultrafilters under RO membranes in hotels that will have a massive reject stream.
Yeah, jumping back to point of entry systems, you say they go up to 1,200 gallons a minute. Is there a maximum they're rated? Say you had a 240 or 400 GPM, is that the maximum rated flow you can put through that system?
Great question, Mike. So ultimately, we size our systems based off of 2 critical variables. One is standard fluid dynamics, right? So you're going to have a vessel that has an inlet of X, an inlet and an outlet of X size, we'll call it 3 inches, right? and then you're going to push water through a barrier or cartridge that is Y, which may be 1 micron. So how much water can we push through so that we stay within that design pressure loss curve? That's part A. The other part is we spent years, quite honestly, fine-tuning these program so that we know we could try to hit annual maintenance cycles. So when we look at our point of entry systems based off some assumptions with water quality, which I know can be a challenge, but based off general assumptions of water quality, especially here in the United States, we want to make sure that we're sizing our systems that they can handle peak demand, because you need to in the hospitality vertical. You have to assume that that hotel is going to be all sold out for a wedding or all sold out for a convention and everybody's going to breakfast, right? But then we also want to make sure we size it so that based off average flow that we could expect for a building, X amount of rooms, right? What's the makeup of it, that we could hit that 4 to 6 month maintenance cycle so that the folks operating the building benefit from having a centralized system that is easy to maintain.
Great stuff. Yeah, if an engineer or a contractor steps into a project where they're trying to decide whether a point of entry or a point of use with hot water system is required, where would he make a decision based on those two options?
Well, quite frankly, it really comes down to budget, as well as the actual Marriott brand. So I'll use an example because I just had a meeting, Mike, last week with a large hospitality group that are developing 12 hotels in the next 2 years. And so we put together a budget analysis for them so that they could see the options based off the actual flag or brand. So off the top of my head, the analysis was if it was an Element branded hotel, what's unique about Element is they actually call for guest room filtration or filtered water in every guest room. So if they go with a standard 240 gallon per minute point of entry system, the cost skidded, delivered to the job site with filters, the whole 9 yards, right, was just over $100,000. If they went with the equivalent standard for that room, and that was a 116 room hotel, 116. If they went with the equivalent meeting the secondary standards, which was domestic hot water for each zone, and then the inline filtration, they were just under $57,000, right? But when you looked at year two point of entry, your filtration cost goes down to around $15,000 annually. Your filtration cost for the in-room option with all the point of use filters only goes down to $34,000 annually. So you can see how the point of entry system catches up really quickly, right? On the flip side, we did the exact same analysis for a Town Place Suites that had 108 rooms. So 116 to 108, guys, we'll call it a rounding error, right? In that particular case, because the Town Place Suites did not call for in-room filtration the way Element did, now you were looking at 100 versus 18, right? Versus 100 versus 54. You lose 116 filters for the building, right? So I would say in that particular case, if I'm a design engineer, I really look at two factors, Mike. I look at what's the flag? Is it a Ritz-Carlton or is it Town Place Suites? Is it a Courtyard Marriott or is it St. Regis, right? Then I also look at, well, who's the developer, right? Does this developer or this group want to look long-term, excuse me, and be able to begin to tie into Marriott Serve 360 marketing efforts and sustainability? Do they want their building to be Serve 360 compliant? Or do they just want to be the minimum requirement for safety? And that's an answer that I don't know, but has been very, in my opinion, been very nicely laid out. So that could be presented early during the design, during the design phase, and that decision made so that efforts are headed down path A or path B.
We had a question pop up, Patrick, about, I know we've been talking a lot about commercial hotels, hospitals and such, but if we're thinking residentially, which filter is best suited for removing like those biological contaminants and heavy metals in a residential application?
So great question. So the simple answer is it's the same, and I'll skip over all this and I'm happy to get into it later. But I thought it'd be best if I just showed a picture while we're talking about it.
Okay.
So whether it's a small filter for an ice machine or a large system for a building, the final water quality and the benefits of force field are the same. So this filter you see here is an under the sink, under the counter, sink filter. That's what would go in every guest room. On the flip side, this filter you see here, that's a whole home system. That's our largest whole home. So we have point of entry for the entire home that starts at 6 gallons per minute and goes up to 15 gallons per minute. And then we have point of use filters that can go under your sink. So from a residential standpoint, point being is that you would approach it the same way as a commercial building. And that is, do you see the benefit of filtering all your makeup water? If you do, there's an option for a point of entry system. Do you see it beneficial to just filter some areas of the home, like your kitchen sink for cooking, or like your primary master bathroom for brushing your teeth and washing your face? Either way, you're going to get the same level of water quality and the same benefit. It's just how you want to approach it. And ultimately, no different than the example I gave for the hotel. It comes down to budget in terms of what you think is the most efficient. But the consistent thing I would tell you is, even though we have a residential line that is really starting to take shape, we maintain the same commercial quality with all of our products, because to us, that's critical. So the same filter that you see here in a commercial food plant in North Carolina is the same filter housing that you would have in your house if you bought it on Amazon today.
Great answer. I'm not seeing any more. Anybody else got some questions for Patrick at this point? You must have done a great job, because they're not loading up really fast here. Either that or they're stunned by your presentation.
Hopefully not the latter.
Yeah, that's for sure. Great. Well, wait, there's one that popped up now. Here we go. That's the same one. So is there, so the same person who asked about the residential one, which water filtration is most effective for removing specific contaminants in the project's water supply, considering both cost and efficiency? And I think you covered that a little bit, based on, yeah.
I'll take a step back. I think this will be helpful. It's a little hard to see, but this is a document we created called Firewall Filtration that Mike could share with everybody after today's presentation. And for us, this does a good job, from our opinion, this does a good job of breaking down the key benefits, whether it be from a safety or a sustainability standpoint, or just an equipment preservation standpoint, that point of entry delivers to your entire building. So ultimately, right, if you took budget aside, by creating a firewall directly after your backflow preventers, you're going to get consistent water to your building that is safe and delicious. But point of entry does not fit every project profile, and we know that. So in my opinion, this becomes the next, by far the most critical area if we're looking at safety, folks. And we've done a tremendous amount in this space. I've got an ASPE presentation that I'm happy to also share with the team if it's something to consider in the future, that I've done probably 6-8 times now. But ultimately, understanding what the water quality is that force field provides, and maybe it'll be good if I take a second and show that. This is what force field is removing. So with a single pass mechanical filter, right, that has no reject stream, there's no wasted water, you're able to deliver near RO quality water with the exception of removing any minerals or salts. So when you look at it from that perspective and being able to include endotoxins or biofilm, when you look at where force field can be applied on your domestic hot water recirculating loop, the benefits are tremendous. So taking a giant step back, as your water comes in, you've got your cold water supply from your building, right? If it's filtered by TripleClear, fantastic. This is still going to show incredible value, right? But if it's not, the example doesn't change. Your water then gets heated. Pick your source. That's kind of indifferent to us. But most important to note here is that we're heating our water now, hopefully, above 140 degrees. The majority of our projects are now seeing set points of 150 because the equipment is so efficient. It allows us now to use temperature as a secondary disinfectant. So primary disinfectant is your city municipal treatment plant. Secondary now is temperature. So we're treating this water. Then from a standpoint of what happens next, the water is treated. As the water is now heated as that treatment, you have taken care of a goal, which is to minimize your microbiologicals, right? So that in itself implies that you have now killed bacteria, right? Simple. As you kill bacteria, you leave it behind. Well, that's now a nutrient. Well, guess what? We now have to pump that water through the building so the water's oxygenated. So anybody who sat through a Legionella presentation, you have a temperature range that's a concern, then you've got nutrients that are concerned, and then the oxygenated water creates an environment for that bacteria to thrive. Well, then at some point in the building, we're going to mix it down to a safe temperature, right? So let's say hypothetically, this building is being fed through a 2.5-inch line or 2-inch line at 180 gallons per minute. It's being fed at 140 degrees. Check, check. System's great. Well, we're designing a recirculation loop, which every Marriott hotel does, which is why this is part of what we're talking about, right? So we're designing that. So now we're peeling off a portion of that water, let's say 15, 18 gallons per minute. We're pushing it through a 1-inch line, and it's already been mixed. So then now that water is being reintroduced. In theory, it would be reintroduced to this heater at somewhere about 110, 112 degrees with a drastically different water profile than the city water was, whether we had TripleClear system or not. So utilizing this as a secondary disinfectant becomes inefficient because the rate at which it's effective is based off contact time and flow rate. Well, you're keeping the same contact time and flow rate baseline as city water makeup versus what's come through the building. Now you take this to a hospital where they're doing biannual flushes of the system, you end up with a massive source of biofilm escalation. So to answer your question, this becomes a critical part of the building that, in my opinion, shouldn't be overlooked, as you can tell, because we've been able to show by putting a simple filter on that return line, you're able to reset the water quality to this level, then introduce it to the heater so that secondary disinfectant is that much more effective. So now your recirculating loop is actually cleaning and maintaining a treatment level versus slowly diluting itself to a point of concern. And then when you go to the final area of point of use filters, it's pretty straightforward. Ice machines, hydration stations. Those are going to be the two areas where you're going to run into the most problems in a building. Hydration stations, quite frankly, because the only filter that's available to go in a hydration station is a carbon block filter. So you fit that profile of concern. And then ice machines, because as you saw by the early examples, they're often forgotten about. So putting a standard filter on there that's not designed to take care of bacteria ultimately puts you in a position of risk.
Do you guys do any special configurations of filters depending on the project?
Yes, I laugh because we've spent the last 2.5 years standardizing what we do. And Devin, who's on today's call, is often referred to what I consider standardized as standardized custom. So, you know, at the end of the day, that's one of the things I absolutely love about our partner in Hurley, because we have the ability to help on a broad scale with projects, but we also, we being they, we being in reverse through them, have some really talented folks that are able to take and either play Tetris, as I would say, where, you know, we may need to look at customized design so that it fits in an existing building, or quite frankly, some of the projects that we've been doing recently where, you know, we and the end user sees the value in force field, but ultimately they really just have a major issue with iron, and that's all they want to solve today. So how do we customize what we're doing so that we can provide something that's cost effective and efficient at solving their problem, which is taking water quality from an area of concern and bringing it to an area that they can operate their building safely.
And I know you standardized some systems. So if someone has a system that they're looking at putting in, once you get a go-ahead, what's lead time on those types of systems?
So we're working hard. The smaller systems are about 12 weeks. The largest systems are 14 to 16.
And on one of the prior slides, you had like a panel with a pressure drop across the filter. Is that something that's field provided, say by Hurley, or is that something you provide?
I'm not sure I understand the question.
There was a filter, a pressure drop gauge on that across the filter on one of the earlier slides. And
yeah,
is that field provided, or is that something that comes from you guys?
Great question. So all of our tanks come standard with differential pressure gauges. I'm glad you brought that up. It's something I definitely could get into in a longer format presentation, but a couple of key points. As we mentioned earlier, the clean pressure loss is 3 psid. Filters are recommended to be changed between 13 and 15 psid. So that's our standard pressure gauge, is a 15 psid gauge. It does have a drag pickup point for an alarm at 10 psid, so that you could tie it into your BMS. With all that said, this is what comes standard in the rest of the country. You can see we use the same one on the domestic hot water systems. I've worked with Hurley now for years, and I know that they've got another partner that does a phenomenal job called Cougar Controls. So they have the ability to customize this so that you can, you could read as much as you want. I know they've got, Mike and team can share with you examples of how that could be tied back into your booster systems or into a larger BMS. So a lot of fun things you could do, especially like, I know there's some cool projects we worked on where, we're recirculating the water in a tank. So it's tying into float and fill valves and all that stuff that's over my head from an engineering standpoint. But that would be a prime example, whether it be the packaging being custom based off your needs, or more importantly, Hurley being, so well known for working with the Grumfuses of the world and other heater boiler companies, and being able to tie all the equipment together with someone like Cougar Controls to make sure that the end product is really slick.
Great. We had one more question about the differences in carbon block filters in regards to the force field. How do they differ in say discussing a breeding ground for biologics?
Great question. One of my favorites to answer. So I'm going to jump to here for a second. So carbon block is an adsorptive material, right? It's an adsorptive property, which in other words, it's very porous. So as water comes in, you base your effective rate of carbon on contact time and absorption rate. So no different than your refrigerator filter or back in the day when Brita became, the rage. Really good at removing a broad range of contaminants. Take it a step further, our founder says all the time, you could trace carbon block filtration back to the Roman Empire in terms of how long we've known carbon is effective at making water taste good. The challenge is, as you can see, it also removes bacteria, right? But it does nothing to mitigate that bacteria. So it's removing your disinfectant at the same time it's removing the bacteria. It doesn't kill the bacteria. So as it continues to remove bacteria, all of a sudden now you've got an environment that's dark and wet, that's very porous, so it's hard for chemicals to get to. in terms of a treatment standpoint. And then the bacteria starts to grow in the filter itself. Again, that's all been widely published for 30 plus years. Why is force field different? Well, force field has 400 layers of these fibers. The fibers themselves are 1 micron in size, so the 10th size of a human hair. But more importantly, those fibers in their natural environment of being wet have a positive charge. Bacteria and virus are negatively charged. So as the water flows through that 1 micron barrier, like I mentioned earlier, force fields are 1 micron mechanical property. As the water flows through those 400 layers, anything that's naturally gram-negative, bacteria and virus, is going to be ionically captured at the surface level. But what sets us apart is, again, bacteria is also being adsorbed, right? So it's like a sponge. When the sponge gets so wet and you squeeze it, it comes back out. We're ionically bonding at the surface level of the bacteria and virus to our medium. But what makes it drastically different is beyond the capturing point that's critical, is that the media itself is a microglass silver. And what's important about that is silver will kill bacteria and virus on contact. So we utilize that charge to capture it ionically, and then as soon as it's captured ionically, it's killed.
Question from Taylor. For particle filtration, says I'm used to seeing a beta ratio for the particle size targets. Do these also apply to Safe Drinking Water Act targets or for TripleClear filter applications as well?
Yeah, so from a Safe Water Drinking Act standpoint, our filters are going to drastically exceed those, Taylor. So again, when you look at it from typical particulate filtration, the majority of the range that we live in, and again, we sell those products too, right? So it's not like they're bad. It's just that in this particular instance, we're talking about taking the ball much further down the field, right? So when I look at our traditional commercial particulate filtration, we live in the 10 to 25 micron range. It's rare that folks want to get much below 10 micron unless we're talking about very specific needs. 25 micron would be my baseline for any building if we were just saying, look, we want to protect that building from water main breaks, or just the fact that we might be in a part of the country where you've got high levels of historical, weather patterns like hurricanes and stuff. 25 micron will be my baseline. We efficiently live every day as in point of entry at 10 micron. In comparison, force field starts at 1 micron before you get into the microbiological component of it. The microbiological component will take you down to 0.005. So 6 log reduction of bacteria and virus.
One last one popped up here. Are TripleClear filters environmentally friendly?
Well, I'd certainly like to think so.
Can
a
it
we
be recycled? Can it be recycled?
Yeah, so the question comes up a lot. So I know I laughed, but we absolutely founded the company. I didn't find it. The founders founded the company as a sustainability company. So I would tell you that we're really proud of where we are, but they are relentlessly looking to continue to push that ball forward. So what does that mean? The filters themselves cannot be recycled because we're capturing all of the contaminant, right? But ultimately, I would tell you that we're able to share, in terms of estimates, in terms of plastic water bottles and things like that. We're able to share how much more efficient it is by having a centralized system, or quite frankly, just a point of use filter in your kitchen sink versus the plastic water bottles that you would consume, or even the 5-gallon jugs. So that's a comparison we make. But right now, the filter media itself can't be regenerated. So that means it can't be recycled.
Well, it looks like you got them all.
All right. Well, always good chatting. Hopefully the team felt it was helpful.
Yeah, got a flood of questions there at the end. That was really, really, really good. So we appreciate everybody chiming in, and hopefully we answered all your questions. Like Patrick said, he'll send me a Dropbox of this presentation so you can take a look at it. The Hurley team will work to get that out to you based on what questions you've asked. Hopefully we've answered those. And if you have any further, please reach out to a Hurley team member and we'll get those answered for you.
Don't forget the cooler, Mike. That's why everybody shows up.
That's right. Yeah. So the winner of the cooler today is Devin Ide from Hurley Engineers. We appreciate Devin and him joining in a lot with our presentations, and we'll have a Hurley team member get that out to you probably pretty soon here. So thanks again. Thanks again, Patrick, for your time and for your knowledge. We appreciate it. And anything else anyone needs, please reach out to Hurley, and we'll look forward to seeing you on our next webinar. Thanks, Devin and Dave, for joining us as well, for helping behind the scenes, and we'll see everybody soon. Thanks.
Thanks, everyone.
Have a
Thanks,
great
Patrick.
day.